Hello everyone, welcome to my channel. Please, if this is your first time viewing, consider to subscribe to this channel so that anytime I upload an exciting video, you notify. I'm going to use two methods to solve this problem on the board. Now let's consider this question on the board. Look at what you are given. You are given that x to the power of 3x to the power of 15 is equals to what 2 raised to the power of 32. We are asked to find the value of x. This is what method 1, right? Now our first step, what you are going to do is to take the what natural logarithm of what both sides. So let's do that quickly. So now become what ln x to the power of what 3x to the power of what 15 is equals to what ln what 2 raised to the power of what 3 what 32, right? Now let's obey one of the properties of logarithm, that the index, remember the index of x here is 3x to the power of 15, right? We'll go back to multiply the ln, right? So now become what 3x to the power of what 15 multiplied by ln s is equals to ln, let's obey one of the properties, right? It will also go back to become what 32 ln what ln 2. That's good. Now what is our second step? Our second step, what we're going to do is to divide both sides by 3. So if we divide the whole of this by 3 and divide this by what 3, we'll now agree that 3 will cancel out from here. We'll now left with what x to the power of what 15 multiplied by what ln s is equals to 32 ln what 2 divided by what 3. Now what are we going to do here? Now we are not wrong if we decide to write what x to the power of 15 as what e raised to the power of what ln s to the power of what 15. We are not wrong because e raised to the power of what, because e raised to the power of ln s is equals to what x by one of the properties of what indices. If you're watching my previous videos I've done, I've proved to you why e raised to the power of ln s equals to what x. So I'm not wrong to write what s to the power of 15 as what e raised to the power of what ln s to the power of what 15. I'm not wrong because remember the base here is e. Okay, then multiply by what, multiply by ln what ln s equals to what 32 ln what 2 divided by what 3. Now what am I going to do? Because there's something I'm going to do here, because I'm looking for a way to take the Lambert-W function of both sides, which is also called what the product of logarithm, right? Now note that s is equals to the Lambert-W function of what into e raised to the power of s multiplied by what x. Now the Lambert-W function of this is the outcome is what x. Remember the Lambert-W function simply means what product of what logarithm. Okay, now look at what you're going to do. I'm having this 15 as the exponent here. It can also go back to multiply the ln as one of the properties of logarithm. So now this is what e raised to the power of what 15 ln what s multiplied by ln what s equals to 32 ln what 2 divided by what 3. Wow, that's interesting. So what are we going to do? Now you can observe that what I'm having here, I'm having 15 ln x as the exponent here, right? 15 ln x. So what I'm going to do, I'm going to multiply this ln by 15, also multiply this by 15, so that I can achieve what I'm looking for. Remember that s is equals to Lambert-W function of e raised to the power of x multiplied by x. And we can see that this s you are seeing here, this s you are seeing here, we can take it as the exponent, which we are also seeing here as 15 ln s, right, as the exponent. But here we're having ln s, but it's not the same thing with what is here, right? So what are we going to do? Let's multiply this by 15, also multiply this by 15 to make this equal, so that we can take the Lambert-W function to have this, because our achievement is to have x, and what will come at the outcome. We are obeying the properties of Lambert-W function, which is also known as the what product of logarithm. Now let's multiply here 15 and multiply here 15 to balance this our left hand side. So now see that e raised to the power of what 15 ln s, okay, multiplied by 15 what ln what s. You can see we multiply this by 15 equals to 15 multiplied by what 32 ln what ln 2 divided by what 3. Okay, then from here now see that now this is what that means e raised to the power of what 15 ln s multiplied by 15 what s is equals to 15 divided by 3 will give us 5, right? So now this is 5, okay, 5 into what 32 ln what ln 2. Wow, that's interesting, because 15 divided by 3 will give us what 5. Now we can take the Lambert-W function of what both sides. So now that the Lambert-W function into e raised to the power of what 15 ln s, okay, multiplied by 15 what ln s, Okay, then before we take the lambda derivation of our left hand side, let's multiply. This time this will give us this is equals to what? 160 what? 160 2. Okay, 5 times 32 is 160. So that means this will be equals to the lambda derivation function of what? Into 160 what? Link 2. Alright, now the lambda derivation function of e raised to the power 15 link s multiplied link s will just give us what? 15 link s, because s is equals to the lambda derivation function of what? E raised to the power of s multiplied by s. To have here as what? 15 s equals the lambda derivation function of what? Into 100 link 2. Okay, now what we are going to do in this method, I have this function lambda derivation function, but we know the calculator I'm using I will share for you guys to learn from. Okay, because it's not all calculators that have this function. That means 15 link s is equals to, let's take the lambda derivation function of this value you are seeing here. So the lambda derivation function of this is what? Is 3.4 what? 465. Okay, 3.4657. That's the lambda derivation function of this value you are seeing here. Okay, now we are going to divide both sides by 15. So if we divide here by 15, also divide this by what? 15, right? Now 15 will go out. So now see that link s is equals to, now this divided and 3.4657 divided by 15 will give us what? 0.23 Now we are going to take the word e of both sides. So that means e of what? E raised to the power what? Link s is equals to e raised to the power what? 0.231. And remember that e raised to the power of s is equals to what? X. That means e raised to the power of s simply e raised to the power of link s simply means x equals to, now the e raised to the power of 0.231 is what? We give us what? 1.259 what? 8. To the nearest what? To 3 decimal place. Let me say to 2 decimal place. That means s is equals to 1.2 sorry, 2 decimal place. Okay, and this is the solution to this particular problem. Now this is what? Method 1. So let's consider what? Method 2. So method 2, I'm going to clean this side, this area. So let me clean it from this area. Okay, so let me remove it from this area so that I can solve. I know that method 2 will not be that long. I'm going to show you an interesting way you can also solve this and have the same answer. But having the knowledge of product of logarithm, which is also not a lambda derivation function, will also go a long way. You can see the value of this is the value of x. Now I'm going to show you another interesting method we can use to apply to this problem. Okay, if you are not subscribed, consider to subscribe to this channel so that you will enjoy our exciting videos. Tell me what you learn about the lambda derivation function. I know having the knowledge of lambda derivation function will help you a lot in most difficult question. Now, sorry that I'm using my bare hands. Now let's consider method 2. Now look at what we are given. Now our first step, what we are going to do is to multiply or put power by by 5. That's our first step. So the answer that this is what? E raised to s raised to the power what? 3s to the power 15 multiplied by 5, because I multiply both power by 5 equals to 2 raised to the power 32 multiplied by 5. You see, we multiply both power by 5. Then 3 times 5 gives us 15. That means s to the power 15 s to the power 15 multiplied by s to the power 15. Okay, because 3 times 5 gives us 15, right? Equals to, there's interesting thing we're going to do here. Let's obey one of our properties of indices. Okay, we consider this as what? Into 2 raised to the power 5 or raised to the power 2. Observe this very clearly. We'll see that you can see that this is multiplication, right? So we can decide to write it because we know that 32 times 5 is the same thing as 5 times 32. Can you see how interesting it is? Now this is in index form. So 5 raised to the power 2 simply means 5 times 5 into 5 places, which is 32. That means s to the power of 15. Sorry, s to the power 15 multiplied by s to the power 15 is equals to 32 32 all raised to the power 32. Now consider that our left hand side is equal to our right hand side, because you can see that we are having s to the power 15 multiplied by s to the power 15, and the power here is s to the power 15, which is the power is s to the power 15, and the base here is s to the power 15, which is the base here is 32. So you can see that s to the power 15 is equals to 30 what 2. Now what you are going to do is to multiply both power by the reciprocal of what 15. Remember that the reciprocal of 15 is 1 over what 15. So now this is s to the power of 15 multiplied by the reciprocal, which is 1 over what 15, equals to into 32 multiplied by what 1 over what 15, right? Now this will cancel out this, then our s will be equals to, now this now become into, let's put 32 in index form, 2 raised to the power of what 5 in index form, then raised to the power of what 1 over what 15, right? Now we now see that s will be equals to 2 raised to the power of what 5 over what 15, because 2 times 1, 5 times 1 will give us 5 divided by what 15. 5 into 5 will give us 1. 5 into 15 will give us 3. So s is equals to 2 raised to the power of what 1 over what 3. Remember, we can obey one of the properties of indices, that this is also equals to what? This implies that s is equals to the cube root of what? The cube root of what 2. And this is the solution to this particular problem. Now observe, the cube root of 2 is presenting as 1.2598 and so on. Okay, so this is the solution to this particular problem. You can see that I used two methods to apply to this problem. So if you watch the video to this end, choose between the Lambda-W function and this other method and drop it in the comment section. Which method is smart? I know you say the second method, but why not learn about Lambda-W function so that you can apply in difficult what question? So thank you so much for watching. Please, if you find it very interesting, don't hesitate. Do well to like, comment, and also share it to loved ones or others who learn from it. So thank you so much, and God bless you.